a carbon dating problem from NEST 2019 Shift 1, question number 9. C14 has a half-life of 5730 years and its abundance in the atmosphere is 1 in 10 raised to 12 carbon atoms. A fresh sample of 0.001 mole of CO2 is collected from the atmosphere and it records a decay of 1700 carbon 14 atoms over a week. A large piece of old wood is burnt and 0.001 mole of CO2 collected from it records a decay of 430 carbon 14 atoms over a week. Then the age of the wood is closest to 8600 years, 11500 years, 2900 years, 1440 years. Okay, so we know that this particular isotope of carbon C14 is radioactive. Okay, and its proportion in the atmosphere over a much longer time scale can be assumed to be constant. Okay, so what it was, let's say 10,000 or 20,000 years ago, we assume that it still is the same even today. Okay, alright, now what is the half-life? Half-life of C14 is given to be 5730 years. Okay, okay. Now look, there are two samples. Okay, first is the sample from atmosphere. Okay, first is the sample from atmosphere, and how many decays does it record? It has recorded 1700 decays per week. Okay, and the other one is what? Old wood, and this records 430 carbon 14 atoms or 430 decays per week. Now one good thing about this particular problem is that they are collecting CO2 with the amount 0.001 mole. Okay, so that's fine, we can directly deal with the numbers now, and these are the activities now, 1700 and 430 decays. What are these? Both these things are activities, right? And that is actually going to help us in solving the problem. This activity is the original activity, or we can say this is the activity at t equal to 0. Okay, t equal to 0, and this is the activity we can say now. Okay, okay, so assuming or setting t equal to 0 when that old wood, I would say, was there. Okay, could be it was about to die, the tree was about to die, so therefore it could not circulate that carbon. Okay, carbon cycle, photosynthesis and all that stuff. Okay, so now we would like to find this capital T where it has decayed to, or it has the decay rate has gone down to 430 for activity. Okay, so what formula do we know? The same formula that we use for the population, n is equal to n naught e raised to negative lambda t. The same formula works for activity. Okay, which means I can say that 430 must be equal to 1700 into e raised to negative lambda t, and that t is our capital T basically. Okay, that t is our capital T, and we need to find that. Okay, now half-life is 5730 years. How are half-life and lambda related? Half-life is ln2 upon lambda. So lambda must be ln2 upon half-life. Okay, Therefore 43 upon 170, I have cancelled the zeros. Okay, 43 upon 170 will be equal to e raised to, let me write it as ln2 first. Okay, raised to negative t by half-life 5730. Have you understood this? Okay, e raised to ln2 into negative t upon 5730. Now we can take log here. Okay, so it will be ln 43 upon 170. Okay, so how much would this be? Negative t upon 5730 into ln2. Okay, cool. Now we just need to plug in the values. Let's do it. ln 43 upon 170. Okay, ln 43 upon 170 into 5730 divided by negative of ln2. 11363. Okay, 11363, option B. That is the closest, right? That is the closest. So it is the estimated life of that wood sample is around 11,500 years. Okay, option B. Now which part of the problem we didn't use? The abundance of C14 in the atmosphere. Okay, we didn't use that because all we were interested in its decay rate, that is 1700 C14 atoms over a day.